With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, we have the question. We have to find whenever limit extends to c, f of x does not exist. So let us start and do it for all the options. First of all, we have f of x equal to greatest integer of x minus x, and we have to see for limit x tends to c. Here we have c as 0, so we need to see for limit x tends to 0 f of x. Let us start. First of all, we need to find LHL at x equal to 0. So here we can write limit h tends to 0 f of 0 minus h. Then we can write h is very small positive quantity, so h tends to 0. Greatest integer of 0 minus h minus 0 minus h. Here h we have a value just less than 0 in greatest integer, and that gives a value minus 1. So we can write minus 1, and here we have plus h, and h is tending to 0, so we can write the value just tending to minus 1. Now coming to RHL part, here we have limit h tends to 0 f of 0 plus h. We need to write f of 0 plus h. So limit h tends to 0, here we have greatest integer of 0 plus h minus here 0 plus h. For a value just greater than 0, the greatest integer will be 0 and h is tending to 0, so here RHL becomes 0. As LHL not equal to RHL, so limit does not exist in case of option A. Limit does not exist in case of option A. Now coming to option B. Here we have f of x equal to greatest integer of mod x minus f of x equal to greatest integer of mod x minus greatest integer of 2x minus 1. Greatest integer of 2x minus 1, and we have to see for limit x tends to c. See here we have got 3 f of x. Now find LHL, and here we have limit x tends to 0 f of 3 minus h. So we can write limit h tends to 0 greatest integer of mod 3 minus h, then minus, here we have 6 minus 2h minus 1, 6 minus 2h minus 1 greatest integer. So 3 subtracting a positive, very small positive quantity from 3 gives a positive value, so there is no use of mod there. So we have that one equal to greatest integer of 3 minus h, and here we have minus greatest integer of 5 minus 2h. For a value just less than 3, greatest integer will be 2, and for a value just less than 5, greatest integer will be 4. So 2 minus 4 gives minus 2. Coming to RHL part, here we have limit h tends to 0 f of 3 plus h. So we have limit h tends to 0 greatest integer of mod 3 plus h minus greatest integer of here 6 plus 2h minus 1. Then we have a value just greater than 3 in greatest integer gives us 3, and a value just greater than 5 in greatest integer gives a value 5. So we have here minus 2. As LHL equal to RHL, so limit exists in case of option B. Option B. Now coming to option C. Here we have fractional part of x square minus fractional part of minus x whole square. So third part, we have f of x here as fractional part of x whole square. Fractional part of x whole square minus x fractional part of minus x whole square. At c equal to 0, we need to find limit x tends to 0 f of x. So LHL part, we have limit h tends to 0 f of 0 minus h. That gives us limit h tends to 0 fractional part of 0 minus h square. 0 minus h here square minus here h square. A value just less than this one gives us limit h tends to 0. We can write 1 minus fractional part of h here square minus this value will be equivalent to h square. Now we have here limit h tends to 0, this value equal to h. So here we have 1 plus h square minus 2h minus h square. H square got cancelled out. 2h will be tending to 0. So we have got the value tending to 1. Now coming to RHL part, here we have limit h tends to 0 f of 0 plus h. We have got here limit h tends to 0. Just substitute these values. So we have fractional part of h square minus fractional part of minus h whole square. So we have got limit h tends to 0 h square minus 1 minus that will be equivalent to this one square, and further we have limit h tends to 0 h square minus 1 plus h square minus 2h. H square got cancelled out, 2h tending to 0. So we have here minus 1, this one tending to minus 1. As LHL not equal to RHL, so we can say that limit does not exist in case of option C. Option C. Now coming to fourth option, there we have limit x tends to, in place of C, there we have 0, and function we have tan signum x by signum x. F of x equal to tan signum x upon signum x. Here we have LHL part as limit h tends to 0 f of 0 minus h. Then we have limit h tends to 0 tan signum 0 minus h by signum of 0 minus h. A slight lesser value than 0 in signum gives us minus 1. So we can write tan minus 1 by minus 1. So we have got tan 1. Now coming to RHL part, there we have limit h tends to 0, f of 0 plus h. There we have limit h tends to 0, tan signum 0 plus h divided by signum of 0 plus h. A value slightly greater than 0 in signum gives us 1. So we have the result as tan 1. In both LHL and RHL we have result as tan 1. So as LHL equal to RHL, so we can say that limit exists in case of option D. So finally we can say that limit does not exist in option C and option A. So we have the correct options are limit does not exist in case of option here first option and third option. First option and third option. So these two are correct options. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.